Hi guys, welcome to the third video of red-black trees. In this video, we will learn insert operation in red-black trees. So first of all, we will see what are the insertion rules and then we will solve an example of insert operation. So if you have not watched the previous video of red-black trees where I have explained the 8 types of imbalances, please go and watch that first because we are going to use those types of imbalances over here when we do the insert operation. So you might not understand the things very properly if you don't watch the previous video. So I request you to first go and watch the previous video and then come back over here to learn the insert operation. So what does the first insertion rule say? It says that if tree is empty, create new node as root and assign black color to it. Okay? So if tree is empty and this is the first node that you are inserting in the tree, in an empty tree, that node should be black. And what about the second rule? So if the tree is not empty, if there is already some node in the tree, in that case, you should create a new node as a leaf node. Of course, you should follow the binary search tree property because a red-black tree is also a binary search tree. So accordingly, you should create a leaf node at a suitable position. You should assign red color to it, right? Now, the next rule, the third rule says that if the parent of the newly inserted node, if it is black, then you should not do anything. Stop over there, your insertion of that node is complete. But if the parent of the new node is red, then you have to check the color of the parent sibling, or as I explained in the earlier video, that the parent sibling is actually the uncle. And if you have seen the previous video, you will understand that if the color of the parent sibling is red, that implies that it is an XY red kind of imbalance, right? So in XY red kind of imbalance, what do we do? XYR kind of imbalance, we just recolor. We don't have to do any rotations. Then what do you do? Then recolor. So there is no rotation. The insertion rule is also mentioning that. And also check for new imbalance at grandparent. So we will learn in one of the cases that what happens is that when we do recoloring, there might be a possibility because we are coloring the grandparent as red. So the parent of the grandparent is also red. So in that case, what will happen? A new imbalance will be created at the grandparent's end, right? So we will take the grandparent as U this time rather than GU and its parent as PU, right? So we will see that example. So this might not happen every time, but we need to check for such a case. If this happens, in that case, again we need to do the recoloring scheme. Again, we need to apply the recoloring scheme, right? So now also check if grandparent is root. So suppose it might happen that the grandparent, we are according to the recoloring scheme, we are actually coloring the grandparent as red, but we find out, okay, the grandparent is root. So in that case, you know the property of red-black tree, that the root of the red-black tree is always black, right? So in that case, we cannot color it as red. So we also need to check for this thing, right? If it exists, if the grandparent is actually root, in that case, we will let it remain as black and we will not color it as red in such kind of imbalances. Okay, and now this was the red kind of imbalances, XYR kind of imbalances. The rest 4 kind of imbalances are the XY black kind of imbalances. I've explained all this in the previous video where I've explained the 8 types of imbalances. So in those imbalances, what do? We actually rotate and then we recolor. Okay, so that is what we do. So if color is black, if the color of the uncle is black or it is leaf nil node, so an external node also we will consider as a black node because you know we have learned in the properties of red-black trees that the external nodes color is also black, right? We have learned it that these nodes are also black, right? These external nodes are also black. We know this already in red-black trees. So if the uncle is actually an external node, so this will fall. So that will fall into this category, right? XY black kind of category. So in that case, we should do suitable rotation and recolor, right? And what will be that suitable rotation? That is what I have explained in the previous video. So now let us do this example where we will insert all these elements and in the red-black tree according to these insertion rules and with the help of the types of imbalances that we have learnt in the previous video. Okay, so the first element is 12. So if we want to insert 12, the tree is right now empty. So we will create new node as root. So 12 will be our root. And according to the first rule, we will assign black color to it. So 12 will have black color and this will also be our root, correct? Okay. So now the next element is 20. So according to binary search tree property, 20 will come on the right of 12, and according to the second rule, the tree is right now not empty, 12 is already present. So we will create this we will create this node of 20 as our leaf node and assign red color to it, okay? So according to BST, it will come on the right side of 12, because again, red black tree is also a binary search tree. So now what about 9? So again, this is the insertion rule. The tree is not empty right now, okay? So we will create this node of 9 as leaf node and assign red color to it, and it will come on the left side of 12 because of a binary search tree property. So it will come on the left side of 12. Fine. So now let us insert the next element, that is 17. So when we insert 17, so 17 will come on the right side of 12 and 17 will come on the left side of 20 because it is less than 20, and it will be assigned red color because now all the nodes will be assigned red color. Why? Because the tree will never be empty right now. We are not performing any delete operation. So we are keep on inserting nodes. So we are keeping on inserting nodes, so that is why the tree will never be empty while we are inserting all these elements. So all the elements will actually follow this rule of insertion, right? They will not follow this rule of insertion, okay, or the rest of the rules of insertion also they can follow. So now we assign red color to 17 and we insert it on the left side of 20, okay? So now you can see that there is an imbalance. The parent is also red and the child is also red. The newly inserted node is also red. So what kind of imbalance this is? It will be right, left, and the color of uncle is red. So this is right, left, red kind of imbalance. So in this case, what do we do? In the red kind of imbalances, we just recolor. So when we do recoloring, what will happen? So in that case, we have to recolor all the relatives, but we actually can't recolor the root because the root will change its color from black to red, but that's not possible. In case of a red-black tree, the root should always be black. We have learned that property in the first video itself of red-black trees, right? So now we cannot color this as red. This will remain as black because it is the root, but the rest of the two elements will actually change their color from red to black, right? So they will change there. So to avoid confusion, this is our U, this is our PU, this is our GU, and this is our UU, right? As explained in the previous video, the newly inserted root, the parent of the newly inserted node, the grandparent of the newly inserted node, and the uncle of the newly inserted node. So we have now inserted 17. Let us insert the next element, which is 18. So if we insert the next element 18, it will come on the right side of 17 following the BST property. Again, there is an imbalance. So what kind of imbalance this is? This is left, right, and where is the uncle of the newly inserted node? Uncle of the newly inserted node is actually over here, the right child of 20. So this is basically an external node because there is no node over here. So this is basically a left, right, black kind of imbalance. So what we will do over here, we have to perform two rotations over here. So let us perform the first rotation. So in the first rotation, what will happen? It will be a left rotation, right? Wherein the parent of the newly inserted node, this is the parent of the newly inserted node. So this parent will actually move down towards the left. So let us perform that rotation. So here, as you can see, the parent of the newly inserted node has moved down towards the left in the intermediate stage, and the child has taken the parent's position, or the newly inserted node has taken the parent's position. Then another right rotation will be performed in order to complete in order to counter this imbalance that is created because of adding 18, because of inserting 18, right? So what we will do, we will write it over here. So in this case, till now I have not done any kind of recoloring, okay? So when we inserted 18, this is the final result, right? So what happened? So basically there was first a left rotation, then a right rotation, and as we learned in the previous video, in such kind of B kind of imbalances or black kind of imbalances, we change the color of the grandparent and the child. So the color of the grandparent was initially black, so it has changed to red, and the color of the child was initially red, it has changed to black, right? This is my U, PU, no sorry, U, GU and PU. Okay, so I am actually not referring to these insertion rules, but this is what I am following over here. Like as you saw in this case, where we inserted 18, we actually saw that the color of the parent sibling, first of all we checked that the parent of the new node is red or black. It was red. 17 was red. Then we checked the color of the parent sibling. So we saw that the color of the parent sibling is basically a leaf nil node, right? So it is following this property. So what we had to do, we had to do suitable rotation and recolor. That's what we did. We did 2 rotations over here. In the first case, we did the left rotation, then the right rotation, and here we also recolored the grandparent and the newly inserted node, right? So we are basically following those insertion rules itself. I'm doing this insert example with the help of the imbalances that I have actually learned. By first of all identifying the imbalance and then countering them with the help of the previous video, right? With the help of what I have learned in the previous video, right? So that is what I am doing. I don't have to explicitly mention that this is the rule that we are following in this case, this is the rule we are following in this case. So they basically boil down to the 8 types of imbalances itself, right? So anytime we will face 8 types of imbalances, or we will face this thing wherein there is no imbalance or the parent of the newly inserted node is actually black. So there is no point of imbalance. Stop over there. That is what it is written over here. Do nothing in such a case. So let us insert the next element. So the next element is 32. So the 32 will come over here, right, on the right side of 20. So what is the kind of imbalance over here? So just to mention the rules itself, the parent of the newly inserted node is actually red. And what is the color of the uncle of the newly inserted node? The uncle of the newly inserted node is also red, right? So in this case, this becomes UU, right? This becomes PU for this U, and this becomes GU. So when the color of the uncle is red, what do? We actually recolor and also check for new imbalance, right, at grandparent. So first of all, we will recolor. So how they'll be recolored? So when they'll be recolored, we will recolor all the relatives. So we actually recolored using the 4-1 rule. Using the 4-1 rule, we actually recolored all the 3 relatives. The color of the grandparent changed from black to red, and the color of the uncle and the parent changed from red to black, and the color of the newly inserted node remains same, right? So this is what we do. Now let us insert the next element, which is 27, right? So when we insert 27, okay, so what was the kind of imbalance over here? It was right, red, correct? That is why we just had to perform recoloring because of the red over here. So when we insert 27, what will happen? Where will the 27 come? It will come on the left side of 32, because this tree is also following the binary search tree property. Okay, so now again there is an imbalance over here, and what is the imbalance? The imbalance is right, left, and where is the uncle of the newly inserted node? So the uncle of the newly inserted node is actually a external node. So external node also falls under this insertion rule, right, where we have to perform a suitable rotation and recolor. So right, left, black. Okay, so now what we need to do? We actually need to perform 2 rotations. So let me first perform the first rotation. So when I perform the first rotation, what will happen? Let us see. So here I have not actually changed the color of any of the nodes. I have just performed the first rotation, which will be a right rotation, wherein my parent will move down towards the right, right? This will move down towards the right, and the child will take the parent's place. So now let me complete this rotation by performing another left rotation, right? And then I can counter this imbalance. So first we did a right rotation, and then after we perform another left rotation, what happens is that the grandparent moves down towards the, this is our grandparent 20, it moves down towards the left, and the child takes the place of the grandparent. And the color of which 2 things change in case of RLB rotation? The color of the newly inserted node and the grandparent. So has it changed? The color of the newly inserted node was red, it has changed to black, and the color of the grandparent was black, it has changed to red. So we are going the right way. So now let us add the next node, and the next node will be, we have added 27, 42. So where 42 will come? 42 will actually come over here, right? This will be 42. So now this is my U, PU, GU. So needless to explain, there is an imbalance. So now you should identify what kind of imbalance this is. This is right, and R kind of imbalance, right? So that is when we added 42. So now we need to counter this imbalance. So if we look at the insertion rule, it is following under which insertion rule? Yes, the parent of the new node is red and the color of the parent sibling is red, correct? So it is following under the 4-1 kind of insertion rule. So let us counter this imbalance. So when we counter this imbalance, when we come from here to here, what we do in such an imbalance, we actually recolor all the relatives. The uncle and the parents, this is the uncle, and the parent's color changes from red to black and the color of the grandparent changes from black to red. But what happens over here? If you have clearly identified, this is what happens. So another imbalance is created on an upper level wherein the grandparent has actually created that imbalance. So in this case, this is what we were talking about here. Check for a new imbalance at grandparent. So when a new imbalance occurs at grandparent, again we need to counter that imbalance. And how we will counter that imbalance? So to counter this imbalance, what we will do is that now we will have a new U and our grandparent will be the new U, and this will be our PU, or the parent of this node that was earlier grandparent, and this is my GU. Okay. So now if we need to change this, what kind of imbalance this is? First let us identify. So we are actually doing the same thing, just this time our U is different because we were actually trying to counter an imbalance at a lower level which resulted in this new imbalance. Okay, so let us, what kind of imbalance this is? This is right, black kind of imbalance. So there is a need for rotation, right? So this is my UU in this case because, and that is why this black over here. Okay, so now let me perform the rotation. So now in this case, we will actually perform a left rotation, right? We will perform a left rotation. So when we were performing a left rotation, this is the result that we got, but this is incomplete. So when I actually brought this 18 over here, brought the parent in place of the grandparent, so I saw that the parent actually cannot be red because it is the root of this binary search tree or the red-black tree. So I had to make it black compulsorily, and this grandparent moved down towards the left side and my child actually moved upwards, right? So now there was one left child of my parent, okay? So where this left child will go? So we need to attach this left child at a place where it is suitable in case of a binary search tree, right? So we need to assign this left child at a place according to the binary search tree property. So 17 will be assigned in that way. So 17 is less than 18, so it will come on the left side. 17 is greater than 12, so it will come on the right side of 12. So this will be, after we perform rotation, this is what we will get after we have inserted 42. So 42 is successfully inserted right now. So now the next element to be inserted is 80, right? So basically 80 will come on the right side of 42. There is no space over here. So 80 will come on the right side of 42 according to BST. So again, as you can see, the parent and the child both are red. So that is not possible according to the properties of red-black trees. So there is another child of 32 over here which will act as the uncle of the newly inserted node, that is U or 80, and this will be my GU and this will be my PU. So now you need to identify what kind of imbalance this is. This is, of course, if you have guessed it right, it should be right, black kind of imbalance. So it requires a rotation, right? So this is actually black, the root cannot be red, okay? So now let us do this. This kind of imbalance, we will actually perform a left rotation, right? And the parent will take the place of the grandparent and the grandparent will move down towards the left. That is why we call it the left rotation, and then 80 will move upwards. So this is what will happen, right? So this is my U, this is my PU, and this is my GU, right? And the coloring scheme I have already explained earlier, okay? So that this does not propagate upwards, we have actually colored this as black itself, right? So this is basically 80. Okay, so now let us insert the next element. So the next element that is to be inserted is 4. So where 4 will come? 4 is actually less than 18, so on the left. 4 is less than 12, so on the left. 4 is less than 9, so on the left. So 4 will come over here. Now if we look at the insertion rules, the parent of 4 is actually, the parent of 4 is black. So it is 9, and 9 is assigned black color. So if the parent of the newly inserted node is black, do nothing. So now the 4 is successfully inserted, we don't have to do anything else. Now let us insert the next element, that is 2. So where 2 will come? 2 will again come on the leftmost side according to the BST property. So here we assign a red color to 2. So when I insert 2, what is the imbalance that is created? So if you have understood it properly until now, you will say that it is a left black kind of imbalance. Left black, right? So this is not you. Okay. So it follows which insertion rule? It follows this insertion rule, 4, 2, right? So actually my parent sibling is a leaf nil node, so I have to do a suitable rotation and then recolor. So let us do a suitable rotation. So what kind of rotation we need to do? We need to perform a right rotation in case of LLB kind of imbalance, and this is what we will get. So this will be our final tree. We have inserted all the 11 elements, and this is what we will get. If you check this red black tree, you will see that it follows all the properties of red black trees. So that's it from this video. I hope now you have understood how to do insertion in red black trees. For a better understanding, you can solve such kind of problems yourself of insertion. In the next video, let us meet where we will learn deletion in red black trees. Until then, share this video as much as possible and let me know in the comments if you like this video or if you have any suggestions.